The object of this experiment is to record spontaneous synaptic GABA-A currents in an adult neuron. This helps us understand the activity of the GABA-A synapses afferent to the neuron being recorded. To record only GABA-A synaptic activity, I add AMPA and NMDA-type glutamate synaptic blockers CNQX and APV to the extracellular environment. I record in whole cell configuration and in voltage clamp mode. Chloride ion reversal potential is at 0 millivolts because I added the same concentration of chloride ions both to the extracellular environment and the medium inside the pipette. I set the holding potential at -60 millivolts. Under these conditions, chloride ions exit the neuron and an inward current of positive charges is recorded. We see a recording of spontaneous GABA-A currents over time passing here. These currents have a variable amplitude on the order of tens of picoamps. This amplitude is variable because the number of GABA-A synapses active at the same time is not always the same. In effect, GABA-A synaptic currents result from a simultaneous activation of multiple postsynaptic GABA-A channels by a GABA release from the axonal terminals afferent to the neurons being recorded. At the time of the analysis, the parameters of interest are the amplitude, the frequency, the rising and the falling durations for each current. To be sure that we are, in fact, dealing with GABA-A currents, we add gabazine, a specific GABA-A channel blocker, to the extracellular environment. After a few minutes, we see that the spontaneous currents disappear. In conclusion, spontaneous synaptic currents provide information on the connection rate of the neurons being recorded. These connections may vary with development or pathology.